Lesson 252, comparing functions in different forms. So this year is going to be our objectives. So by the end of this lesson, we hope that we are able to compare linear, quadratic, and exponential functions. And 2, compare data that is given via table, function, or graph. And we're also going to include statements in this. You don't have to write it there, but just know that we're going to be working with statements. And just a little review. So linear functions, right, this is what we worked with in Math 1, are y equals mx plus b. Right, b is your starting amount. That's your initial amount. M is your rate of change or your slope. Okay, then we have our quadratics. We've been doing this all year. This is when you have y equals ax squared plus bx plus c. And then we have exponential functions. So exponential functions, most recently the exponentials we've been working with is y equals, that is incorrect, y equals a times 1 plus r to the t power. Right, so if we're looking at the t is an exponent, that makes it an exponential. Our vocabulary, we have our functions, right? Numbers, variables given in that form. We have data given through graphs. We have data given through tables and statements. Right, so if you look here, the highest bird flew 50 feet, or 30 feet, sorry. The highest the bird flew was 30 feet. We know that the maximum this bird flew was 30 feet. Prerequisite skills, this should have been an activity we did in class, and it was the one where we compared functions. So it was the introduction to this lesson. So example 1, which function has the greater y-intercept? So we're looking at f of x equals 8x minus 2, or g of x equals 2 times x minus 3 times x plus 1. So to recap, to find the y-intercept, we have to plug 0 in for x. So we're going to take our first equation there. We're going to plug in our 0. F of 0 equals 8 times 0 minus 2. And I'm going to skip the calculations a bit just because this is all review. We've done this before. So then this gives us 0 minus 2. Negative 2. So f of 0, the function of 0 was negative 2. So our y-intercept here, 0 comma negative 2. Right? Y-intercepts, x is always 0. So now going on to g of x, so we're plugging in 0 equals 2 times 0 minus 3 times 0 plus 1. Simplifying this all out, this will turn to 2 times negative 3 times 1. 2 times negative 3 is negative 6 times 1 is just negative 6. So g of 0 gives us a negative 6. So our y-intercept here, 0, negative 6. Now we got to go back to the directions where it says, where it asks which of the function has a greater y-intercept. So we have the two y-intercepts. Now we need to compare them. So this y-intercept is at negative 2. This one's at negative 6. If we look at it on a chart, if you're having trouble determining which one is the greater y-intercept, if we were to plot these 2 points, let's say negative 2 is here, negative 6 is here. Whichever one is higher up on the axis is going to be the greater y-intercept. So negative 2 is the higher one. Right, negative 6 is down here. So negative 2 has the greater y-intercept. So this here is our greater y-intercept. So we just have to make a final statement, and this will be our answer. F of x has the greater y-intercept. Right, and the proof is in the math. So next one, we got 3 students here who are throwing wads of paper with a rubber band aiming for a trash can in front of the room. The height of each student's paper wad in feet is given as a function of the time in seconds. Right, so x is in seconds, y is in feet. Which student's paper wad flies the highest? So this question actually tells us the point that we should be looking for. If we're looking for the highest point, right, we know that the minimum and the maximum occurs at the vertex. So for these, we are looking for the vertex. So for all these, we need to find the vertices. Looking at the first one here, the path of Alejandro's paper wad is modeled by the equation f of x equals negative x squared plus 2x plus 7. That's in standard form. So I know to find the x value, again, this is review, we use x equals negative b divided by 2a. Right? A is negative 1, b is 2, c is 7. And we just plug in all the points that we have. You are welcome to use decimals for this. It makes life a lot easier. But for this one here, simple calculation. So 2 times negative 1. So simplifying this out, this gives us negative 2 over negative 2, which equals 1. So we have the x value of our vertex. Now we need to find the y value. And the y value is what tells us how high it goes. All this tells us is that after 1 second it goes to its highest point. But we don't know what that height is yet. So standard form, after you find the x value, to find the y value, you plug it back into the equation. Okay, so you'll have negative, and then when you plug in, you want to put in parentheses, so the 1 goes in parentheses, squared plus 2 times 1 plus 7. You pull out your calculator. That's negative 1 plus 2 plus 7, which is 8. And your final vertex here is 1, 8. Now, looking at the second one here, right, so we're looking at Melissa. I'm just going to draw a little sketch here. And we're given her information from a table. So we got 0, 3, 2, 6, 3, 7, 4, 6. So we know parabolas travel in parabolic shapes. Right? They're traveling this bell curve kind of thing. So if it's going, notice here it's going higher, 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 and then it starts coming back down. Right, so it goes higher, and it starts coming back down. So that kind of tells us that it's going higher, 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 reaches the maximum, and it starts coming back down. So that tells us that that point before it starts coming back down is where the vertex occurs, right? Because that's going to be the peak. 7 is the highest point there. If we have trouble figuring out or just extracting it from the graph, what we can do is make a quick sketch. So let's say 0, 3 is here. 2, 6 is about here. 3, 7 is here. And then it falls back down to 4, 6. So this makes it a little more clear to see where that vertex is, that point right there, and that was the 3, 7. So the vertex here is 3, 7, right? Didn't have to do any math there. And now Connor, we're given a statement for his vertex. So after 3 seconds, Connor's paper wad achieves a maximum height of 6.5 feet above the floor. So after 3 seconds, x is seconds, it reaches a maximum height of 6.5 feet. So that's his vertex there, right? The maximum occurs at the vertex. So the question was, which of these fly the highest? So if we're looking for the highest, we're looking for the y values. This one's 8, and Alejandro's goes 8 feet up in the air. Melissa's goes 7 feet up in the air, and Connor's goes 6.5 feet up in the air. So analyzing these, we choose the largest number, and Alejandro's travels the highest distance from the ground. our last example. So we want to invest the money that we received from winning a beauty contest, right? And of course, Mr. Plotz is going to win first place. He's the prettiest person on the planet. So we got second place. Okay, so if you look at our little Monopoly card here, we collected $10 for being in second place. Okay. So again, we want to invest this $10, and we're going to invest it in either scenario 1 or scenario 2. So scenario 1, you earn $2 every year on your initial deposit. So for this one, we're going to have to write our equation. So $2 every year, right? So we have 10 total years. So if I make a little 3, 4, 5, so on. Every year, right? This is year 1, year 2, year 3, year 4, 5, 6. Every year we're getting plus $2, right? So if we see the rate of change, that's 2, 2. It remains the same every year. That means that we have a linear function here, right? It changes the same amount each year. So if it's a linear function, we know we're using y equals mx plus b. Right? Again, b is our rate of change, m is our rate of change, and b is our starting amount. So what we started with was $10. That's how much we won from the beauty contest. And the rate of change is changing $2 every year. So when we plug that information, we got y equals 2x plus 10. And now looking for the interest one, right? We're given a rate here. We have a rate of 10% annually. I'm going to change this to a decimal, 0.10. Right? And we're looking for the annual rate. So for annual rate, we're going to use the most recent formula we learned. Y equals a times 1 plus r to the t power. And we plug in the information that we know. We got y equals, a is our starting amount, 10 times 1 plus, our rate is 0.10 to the t power. So we have our two equations now. We can start answering the questions underneath. Okay. So now it's asking if you wanted to save the money for 10 years without withdrawing or without taking out of the account, what would be the better option and how would you know? Okay, so we've got to start plugging in and figure that out. So we're looking for 10 years. So the first one, if you plug it into it, we got y equals 2 times 10 years has passed plus that initial $10. So y equals 2 times 10 plus 10, that gives us $30. So after 10 years, if we invest that $10 in the first account, we now have $30. If we take that same $10 and we invest it in the second account, so we got y equals 10 times 1.10, and I just went ahead and added these. 1 plus 1.1 is just 1.10. And our exponent is going to be 10, right? Because we're looking for when 10 years passed. So when 10 years passed, we're going to have, put it in your calculator, $25.94. So now, analyzing these two here, we got to determine for 10 years which one of these accounts is more beneficial to invest our money in. So we invest in the first account, we get $30. Invest in the second account in 10 years, we get $25.94. So again, if our money's going to stay in that account for 10 years, the better option is to put it in scenario 1, where you get $2 every year, where you get that linear function. Now this second one, is asking which one's the better option if you leave your money in there for 15 years. So we have y equals, right, instead of 10, we're plugging in 15 this time. 2 times 15 plus 10. Put that in our calculator. 2 times 15 is 30 plus 10 is $40. And now for 15 years in the second scenario, y equals 10 times 1.10 to the 15th power gives us 4177. Right, and I got that from a calculator. So after 15 years, we look at those two numbers and we determine which one of these is the better option to invest in. And again, you always want more money. I haven't ever heard of someone complaining that they have too much money or more money. So option B or option 2 is going to be your best bet if you are to take your money out 15 years later.